Hey, if you'd like to earn CEUs for this webinar, join the Safeopedia community at the link in the description below. Now, on to the show.
Hello and a warm welcome to everyone. We would like to wish everyone a good morning, a good afternoon, or a good evening, depending on where you are in the world. My name is Samantha from Safeopedia, and here at Safeopedia, it is our mission to serve all of our EH&S professionals, operational folks, and any safety-minded individuals with free safety information, tools, and education. I'd like to extend a huge thank you to all of our dedicated safety professionals for the great work they do on a daily basis. Today, we are proud to present a webinar from DuPont, presented today by DuPont, a preferred manufacturer of AD Safety Network. It is now my pleasure to introduce to you today's presenters, Dan Hirsch and Matt Miller. Today, the DuPont Personal Protection Team will help you discover the critical importance of recognizing workplace hazards across different states of matter, solids, liquids, and gases, and how to choose the most appropriate protective apparel for each scenario. I am very happy to have you all sit back, relax, and enjoy this presentation. With that, Dan and Matt, let's jump into it.
All right. Thank you, Samantha. I appreciate that. So as Samantha alluded to, today we're going to be talking about what's the matter, focused on the different states of matter, what potential challenges come with those, and the solutions that we offer from our portfolio to help in those situations. So I'll dive in. So when we're looking at the states of matter, we're really focused on the industrial manufacturing segment for this presentation. And the reason is kind of what you see here on the slide. So industrial manufacturing has a wide array of different businesses, industries, products, you name it, which also comes with a wide range of applications and hazards. So this segment's unique because all these companies lump into that that manufacturing environment, but they all do different things. So it's important to highlight that while we're talking through these different hazards. So before we even get into selecting a certain PPE garment, we want to first identify why we're talking about PPE. What's the importance of it? And per OSHA 1910.132 to be exact, the selection of PPE is the responsibility of the employers. So OSHA gives a very open guideline in terms of, hey, you need to have something for your environment, but it is up to you to decide what that is. And that's where we come into play. Other organizations, other distributors come into play to help with that selection and help with giving the end users the tools to make those selections. So with that, the first key step in doing any of this is identifying the hazard and doing a risk assessment. So what that does is that helps paint the picture of not just the chemical hazard, but also the environment as a whole. What are they dealing with when they're working with a chemical, whatever that hazard may be? What does that environment look like? So this helps us not only narrow down the actual PPE, but gives more into the details of some of the nuances that come with selecting the fabric, whether it's seams, things of that nature. And then the other thing to identify here is that even though PPE from a control standpoint is the least effective, right? So it's the last line of defense. I would say that it becomes one of the most important when we get down to there, because that is what's protecting the worker at that point, right? So not only is the hazard assessments good for identifying the right material, but we also want to make sure that the individuals are protected to the fullest based on what they might be dealing with on site. So when we dive into the different states of matter, it's important to identify that not only are these states of matter different, but they also have some similar characteristics. So what you can see from this Venn diagram, as we look at solids and liquids, we know that there could be a potential for an aerosol mist. As you look below that, biologicals, if you're dealing with some type of biohazard, they can be liquid, mist, or solid, depending on how you're dealing with them in your environment. And then as we position over to the right, we look at the liquid and a vapor or gas. Well, some liquids actually are gas producing. So it's important to know those, because if we get into those different situations, different scenarios, we got to be making sure that we are nimble and addressing those hazards in those certain situations. So we're not just solely focused on liquid, solid, and gas by themselves, but also being able to identify that there may be some overlap when we're working in those settings. So OSHA and EPA identifies 4 levels of protection. Level A and level B is probably the most common nomenclature that we hear within the industry, within the market. When it comes down to level C's and level D's, we don't usually advertise them as such, but they are just as important. And as we're looking at these levels, as you can see from this chart, we're really focused on a few categories. So first and foremost, for us, skin hazard is always going to be near and dear because we are a disposable garment company. So we are protecting the individual, protecting their body from said chemical challenge. The other thing to note too is that even though we're not in the respiratory business, our suits play an important part in identifying those respiratory hazards. So for example, if you're in a level A, you might be wearing some type of SCBA. So we've got suits that are designed to make sure that the person can move around, that they've got some room inside the garment when they're wearing those SCBAs, that they're as comfortable as they can possibly be in that environment. The other piece too is if you're dealing with a lower level of protection, you might be wearing some type of respirator. Well, we have suit options that come with respirator fit hoods or even elastomeric seals. So not only does that protect the worker from a skin hazard, but we also have it configured so they can wear a respiratory protection as well and keep them just as protected. So this next slide here really just paints a picture of what each of these levels look like from real world examples. So I'm not gonna dive into this in full detail, but as you can see from a level A, we could assume that that's going to be the worst of the worst, right? They're wearing top of the line suits, boots, gloves, you name it. They're dealing with potential lethal state of matter. And as we move down the list of levels, what's happening there is we're sacrificing some areas. Maybe we don't need as much of a respiratory concern, or maybe we need more respiratory concern but less skin protection. So it just depends on the environment and what you're dealing with. But this is important to note because we want to make sure that as we're doing these assessments, as we're talking through these different chemical challenges, that we are lining up the right level of protection. Because, for example, a level A is going to protect against a hazardous particle, but you might just need to be in a level D in that situation. So just making sure that we are taking everything into account and that we're factoring in the right possible configuration for said environment. So before we dive in, the purpose of this webinar is we're going to focus on solids, liquids, and gases. We're going to talk about the potential challenges that come with them, understanding how to assess those challenges, and then kind of taking that assessment, if you will, and putting it into a garment that would work in those settings. And as we're talking through these different states of matter, we want you all to consider a couple options here when it comes to selecting the apparel. And we really look at from left to right as the most important. So first and foremost, protection is going to trump everything. So the goal of this is to make sure that the worker, that they're protected from the environment, that they can leave in better shape or the same shape that they arrived in to start their shift. The next piece is durability. So when we say durability, it's not just from, hey, we're in these suits all day and we're testing these to the limit. The seams are getting tested, but also durability from the chemical. So making sure that they are being protected from whether it's 8 hours of exposure, whatever that may be, that the suit itself is going to hold up from being exposed to the chemical throughout the day and throughout somebody's work shift. And the last piece here is comfort. Comfort comes up a lot in our world, but I would push against that and say when it comes to protection, comfort is going to come last. A lot of cases when it comes to what you're dealing with in an environment, the comfortability piece is something that we can try to help with, and we'll talk through some different areas where we can look at comfort in certain situations. But when it comes to wearing a protective garment, a lot of times that's condition of employment. So at the end of the day, we want to make sure that they're protected first and foremost. So without further ado, I will turn it over to Dan to kick us off with solids.
Thanks, Matt. So the first state of matter we're going to talk about is solids and what the protective apparel solutions for hazardous and non-hazardous particles are. So in industrial manufacturing, workers can come into contact with a variety of different particles, and we want to protect them from 2 points of view. One is to keep it off of their clothing and off of their skin, and the other thing we use PPE for is to make sure that we're not taking those particles home. The last thing you want to do is cross-contaminate your car or your home with some of these hazardous and even non-hazardous particulates. So those are two real basic and important considerations. Some of the hazards can be things like asbestos, lead, or fiberglass silica, and they can be hazardous or non-hazardous. Next slide, please. So what is DuPont's solution? So DuPont has a product called Tyvek 400, and it is an ideal balance of protection, durability, and comfort. And what it does is provide an inherent protective barrier against particulate matter down to 1 micron in size. And we'll kind of talk through that a little bit and how it sets itself apart from the competitive fabrics that are out there. Again, you can have hazardous or non-hazardous particles, anything from dirt and grime to asbestos, lead, and silica. And we see it used across a wide variety of tasks within the industries, whether it's maintenance, wind turbine manufacturing, or composite manufacturing, food processing, environmental remediation. Tyvek is used in a wide variety of different applications, and we'll talk through that a little bit as well. We've also done a lot of work on the design of the garment itself, kind of speaking to comfort like Matt was alluding to. It's a definite consideration if you're wearing these for long periods of time. And we've done a lot with input from our end user base in designing and building these garments to be as comfortable and easy to move in as possible. Next slide, please. So let's talk about Tyvek and what it is. And so all white suits might look similar, but Tyvek makes the difference. So Tyvek is made only by DuPont with a proprietary flash spinning process that creates continuous fibers of high density polyethylene. These fibers are randomly distributed and they're non-directional. So what this does is it creates a tough, continuous, inherent protective barrier, again, down to particle size of 1 micron, and it also protects against light liquid aerosols. There's a lot of attributes that we're going to speak about in the next couple slides, but really it is a tough, lightweight fabric, very durable. It breathes very well. It gives you light aerosol splash. And an important thing that a lot of people might not know is it also is a great it's inherently low linting, so it's very good for controlled environment applications as well as industrial applications. Next slide, please. So this is kind of a fun demonstration. It's a video showing the durability of Tyvek, and we're trying to get a little creative with it. So it's our paintball video. Go ahead and start it whenever you can, Matt. And what we did is we set up a booth where we shot paintballs at garments. And you're going to see the difference between the three different main styles of fabric that are in white suits. So the first one we're going to do is we're going to shoot at a microporous film garment. So that kind of shows you the velocity. I think actually this first one is Tyvek, just to kind of demonstrate what we're doing with it. But here's the microporous film, shot 1, 2, and 3. And afterwards, we're going to show you that this fabric failed. So not only did the paint come through, but actual holes got blown through the fabric as well. And so microporous film is just one of the white suit fabrics that are on the market, and it's why we stress that you have to make sure that you know what your customer is using, what they're doing, and what they're being subjected to. SMS is the next fabric. It's a very open substrate. It breathes real well, but it doesn't do a lot to protect you from the paintball or from hazardous particulate. So again, it failed after 3 shots. This is what Tyvek looks like. Exact same scenario, 3 shots, and you're going to notice there's no material penetration at all. No paint made it through, and there's no holes in the fabric. So it's intact. And so that kind of demonstrates the durability of Tyvek and one of the things that make it unique. And it's, again, why you have to look at what fabric the white suit is made out of. People will say all the time, yeah, quote me on Tyvek, and you need to verify that that's actually what they're using. And if they're not, be able to describe to them the differences and why Tyvek is a superior solution. And please don't go shoot your end users with paintballs, as much fun as it would be. So the next video that we have that Matt's going to queue up actually talks about the air permeability of Tyvek. And I'm going to let Mr. Dan Bone take it away and describe what's going on here.
We're going to use the bubbler kit to illustrate the breathability and durability of Tyvek versus microporous film. I have two different fabric swatches in front of me. One is a microporous film. The other is DuPont Tyvek. And what we're going to do is we're going to start with the microporous film. Manufacturers of this material make the claims that it's a breathable material. They use the term microporous film to describe it, giving you the impression that it has pores in it. What's going to happen is I've clamped it in this chamber. There's water in the bottom. I've got a bulb that when I squeeze it, it's going to put air pressure on one side of it. I turn this upside down. When I squeeze that bulb, if this material was breathable, you would certainly expect air bubbles to be coming through. It is completely unbreathable. It is a plastic coated fabric, and that plastic coating on there makes this completely unbreathable. So contrary to the manufacturer's claims, microporous film is not a breathable material. One of the challenges with microporous film fabrics as PPE is that the protection that this fabric has comes from that very thin layer of plastic. So if I take my fingernail, which isn't particularly sharp, and I try and scratch the surface of that material, and now I repeat that exact same test, I turn it over, when I squeeze it, oh, now it's highly breathable. The reason it's breathing is I've compromised the protective layer that's on the surface of that material. And oh, by the way, over time, water will come through the bottom of it as well. So microporous film, not only is it not breathable, but the protection that you count on to keep your workers safe is a very, very thin layer of plastic, which is very easily damaged. Now let's do the same thing with Tyvek. If I put Tyvek in here, I clamp it on the chamber. Tyvek is indeed an air permeable material. It's highly breathable, right out of the box. Tyvek breathes just fine, right? And the nice thing about Tyvek is the protection that you get, the particle holdout and the protection you get from Tyvek isn't a treatment. It's not a surface treatment. It's not a thin layer. Tyvek is Tyvek through and through, all the way top to bottom. I can scratch the living daylights out of that, put it back in there. It's still going to be breathable, but I have not breached that fabric. Water is still not going to come through it. I've not compromised the performance of the Tyvek protection. So that is the bubbler kit, and that's what we use to illustrate both the breathability and durability of Tyvek versus microporous film.
Okay, I think it's a pretty good demonstration to show how breathable the fabric is. Another area that we can talk about as far as comfort goes is the different styles of garments that we manufacture. So it might not be that you need a full coverall, and the protection you need is your sleeves or your upper body, so a lab coat will work. And again, if we're not covering the entire body, it's going to be less heat stress and be a more comfortable solution. Believe it or not, we sell more sleeves than any other style of garment that we manufacture. Next slide, please. And back to you, Matt.
Thank you, Dan. All right, so I'm going to focus on liquids, particularly hazardous liquid chemicals within the industrial manufacturing segment. And the key things is that we're going to focus on for this example is highlighted there in red, and we're going to focus on if we're going up against industrial cleaning chemicals, acids, and bases. When it comes to acids in particular, it's widely used across the industry, whether it's for pH balancing, whether it's used as a catalyst, and even used in actual production segments such as steel manufacturing or battery manufacturing. So it's an important piece. It's used throughout multiple types of businesses. So it's something that that we'll see across the board. So when it comes to those type of challenges, we like to position our Tychem 2000 for those areas. And the reason why we do that is for a couple. The first one is it's lightweight. So at its base fabric, Dan talked a lot about Tyvek, our flagship product, right? So this product at its base is made from Tyvek. And then what we do over top of that is laminate a chemical barrier, which gives you that protection against those liquid challenges. The other piece too is it's durable. So again, going back to the Tyvek properties and some of the example videos that we showed, you're also going to get that durability piece with it as well, which is going to be important, right? We're dealing with some pretty nasty stuff depending on the environment, and we want to make sure that we're protected as such from those. When it comes to the range of protection, so we do offer, this product does offer at least 30 minutes of protection against greater than 40 chemical challenges. Again, a lot of acid and bases, some industrial cleaning is kind of the core for this suit. On top of that, if you're in a biological setting, for whatever reason, this garment, when you do purchase this or do use this as a tape seam option, it does meet the industry requirements for blood and viral penetration as well. So it's kind of like a Swiss Army knife of a suit. During COVID, this suit was widely used. So it holds the test of time. It's been used in real world settings. This is a very, very popular chemical suit that we offer. So just as it's important as picking the fabric, it's also just as important to make sure you've got the right seam. So when it comes to seam type classifications or making sure you're in the right seam, the reason why we focus on this is for a couple of things. So the durability piece could be one, but most importantly is the protection. So when it comes to a seam, that could be the weakest point of a suit, depending on your area, depending on the environment that you're in. So it could be an entryway when I say the weakest point, for whether it's a gas, a liquid, or a solid for that matter. So again, it's important as we're doing these assessments and we're having those conversations that we do address the seam type. And I'm going to touch on each of these seams that we offer. So the first one there is what's called a surged or sewn seam. This is a very, very popular seam. It's all of our standard Tyvek 400 garments come in a surge seam. So again, it's one that we see a lot in the market, but this is kind of like a shirt, right? So you've got two pieces of fabric put together, and they are sewn. So that's it. So again, you can kind of see based on a potential for an entryway, depending on your environment, you can see that a surge seam might not be the right situation for you or the right seam classification to use for your garment. The next one is what's called a bound seam. So again, it's seams that are sewn together. We take it a step further and we actually add a secondary layer over top from the fabric that's on the suit currently. So what that does is that increases the seam strength, and it also increases the barrier protection as well. And then we get into our tape seam options. So we have what we call just tape seam. So you see from the picture, again, it's going to be a sewn seam, and then it's going to be a piece of compatible tape over top. So that gives you an added layer of protection if you're going up against like a heavy liquid splash, something like that you would make sure that this, in this case, is going to be more of a liquid tight suit. And then we get into the double taped seams. So this is going to be more, and Dan will talk on this here in a little bit, but this is going to be more of your level A environment. So something where you're looking for like an airtight and liquid tight. But this is going to have tape seams on the top outside of the suit and the inside of the suit. And the flap is actually folded over as well. So that's the strongest option that we have. The reason why we highlight these seam types in this situation is that our Tychem 2000 comes in 3 of the 4. So not only are you getting the protection you need from a fabric standpoint, but we are able to then look at the different seam options and fit you in within that same suit style, if you will, or fabric style, within those different seam strengths, depending on the environment. So I talked about protection. When we say we have protection data against greater than 40 chemical challenges for the 2000 fabric. And when we talk about protection, there's 2 different considerations. So the first one that we have here is what's called penetration. And penetration is just that. So it's something that we can visually see. There is no scientific method to it. And that's when material is getting through, whether it's a seam, whether it's a gap in the suit, it's a material defect, what have you. You can physically or visually see the chemical or the material getting through the garment. The other one is permeation, and permeation is much different. So it is quantitative. This is when the material is actually moving through the barrier fabric at a molecular level. So when we measure our garments, we measure permeation down to 0.1 micron in size. So whenever you see our testing, and I'll talk on this towards the end of this webinar, but when you see our testing data, it's going to be tested down to 0.1 micron, which is something we cannot see with our eyes. It has to be scientific method testing to actually verify that that chemical is getting through. And the reason why that's important is because when it comes to a lot of these reusable garments, we see this a lot with some of our reusable PVC acid suits that are in the market. They only have to test on penetration. So if someone's wearing that suit for hours on end, and they get some type of acid on them, a lot of these companies are not testing based on the permeation time it takes for that chemical to work through. So a telltale sign of that is if you're ever looking at a tech data sheet and you see a particular suit that's advertising greater than 60 minutes, that is more than likely something that has been tested against penetration methods. Versus when you see, such as our data, we're going to test up to 8 hours. That is a permeation test method. So a lot of times for our garments, you'll see greater than 480 minutes. That's a telltale sign. Just a quick little tidbit if as you're looking at garments, if you're figuring out what's being tested against penetration versus permeation. Permeation is important because it's something that, again, we can't see. If for whatever reason a person wanted to reuse the garment, having that data is important because depending on the chemical challenge and depending on the fabric, that chemical may not hold out for 8 hours. So, and I'll touch on that here on the next slide, but it's very, very important that we are looking at this because this is really what gives us that sign of what kind of level of protection that we're going to be going up against when we're looking at particular fabrics. So this slide here demonstrates real actual data for our Tychem 2000 fabric in this situation. And as you can see from this snippet, this isn't all the chemicals that test against it, but from this snippet, you can see that majority of them test out under that normalized breakthrough within minutes. They test out greater than 8 hours. The one thing I wanted to focus on here is towards the middle of this chart, we see some chemicals that are not testing to 8 hours. So for example, hydrofluoric acid, up to 51% concentration. It's a widely used chemical. It's a pretty nasty acid. When it gets on your skin, it eats through it. It likes calcium, which we're made of. So it's something not to mess with. And as we can see here, the breakthrough time from our testing on this suit is 280 minutes. So the reason why we want to make sure that we're understanding the hazard is because if we just lump an acid, if we lump hydrofluoric acid with sulfuric acid, those two have they're two different acids. They do two different things. And they also have different breakthrough times. So we want to make sure that we're not just we're not just saying, hey, this suit is good for acids and bases, put in this, go, try this suit out. We want to make sure that when we're having these assessments, that we are looking at the chemicals individually, or we're looking at them if they're being mixed together, what have you. But nonetheless, we want to make sure that we are identifying the particular hazards that are being going up against at those sites. So I've talked a lot about protection. Again, that's the key focus here, is making sure we've got the right protection. So now we're looking into durability considerations. I touched on this earlier. The durability piece is there with this particular liquid protection garment because of the Tyvek as a base fabric. So you are going to get those properties, those characteristics that we know from regular Tyvek or Tyvek 400 line. The comfort consideration is key. So we do make this garment in some different styles. And the reason for that is, depending on the environment, they may only need an apron, whether it's a standard apron or they want a sleeved apron or even just sleeves by themselves. So it's not always, hey, if you're dealing with, something where you just need to wear sleeves, you just have arm exposure, you don't need to put them in a full-on coverall, right? So this is where that comfort consideration comes into play with these kind of suits, because we're not going to advertise these suits as breathable because they've got barrier fabric. We want to protect them first and foremost. But with that being said, we've got options out there that can help in those certain situations to help the worker be a little bit more comfortable in those settings. So with that said, I will turn it over to Dan to talk about gases and vapors.
Thanks, Matt. So the last phase of matter we're going to discuss are gases and what are the protective apparel solutions for hazardous vapors and gases. So again, industrial workers can come into contact with a lot of different gases, ammonia, chlorine, and many others. They're very common. You're going to run into a lot of those in food processing and in breweries. I actually have run into Anheuser-Busch has a lot of ammonia on site, and so they have a number of level A's that they keep for hazardous response, and it's more common than you might think. Many industrial manufacturing workplaces have hazmat teams on site, whether it's a refinery or a cold storage facility, and they're going to have the need for some of these level A suits. Next slide, please. So what is our solution? Our solution is Tychem 10,000, and it's going to give you the highest level of protection against liquids / vapor gases and particles. So a level A suit, what it does is it builds its own environment that you're inside of and safe. And so it requires a supplied air of some sort. Most typically, it's going to be an SCBA. Occasionally, there will be airline applications, but that's a very small percentage of the level A suits that are out there. They're almost always SCBA so that you have the mobility and ability to move around within a facility and do the task you need. So it's going to provide you with protection against toxic corrosive gases, liquids, solid chemicals, and we've tested it at least to 30 minutes for over 320 chemicals. So this is a very robust fabric, and it is very durable and it's thick. Also don't want to give you the impression that we jumped straight from 2,000 to 10,000. We have several different fabrics in between, Tychem 4,000, 5,000, and 6,000, and the selection of those is really based on what the hazard is. So we want to go back and look at what that hazard chemical is and select the right fabric material, and then look at the task you're doing while you're in the suit, and that helps you select the garment style. We also have level A suits that meet NFPA standards. NFPA 1990. You won't typically run into that on the industrial side. That's really on the government side of the business. A lot of grant money is tied to those at the firefighter level, hazmat teams, and in federal and state agencies as well. Next slide, please. So some of the classifications as far as the seams go, Matt covered very well. And really the only thing that I want to mention here is we double tape our level A suits. And that's real important, not only from a maximum barrier protection, but also from a seam strength. So you have that confidence that that seam is not going to leak. Some of our competitors only tape the outside of some of their suits. So you really need to look at that and make sure you're able to speak to that to your customers. Double tape seams are the only way to go in a level A suit, in my opinion, because it gives you that confidence. It gives you the maximum barrier and the maximum seam strength. Next slide, please. So we've done a lot in recent years to redesign our garments based on feedback from end users. We've always had that EX face shield, extra wide face shield. That really helps if you've ever been in one of these suits. It makes it so that they're less claustrophobic. It makes it so you're not grabbing the suit hood and trying to reposition it to see what you're working at down at your knees or below. And we've also put an anti-fog coating on the inside of it to help eliminate or reduce the fogging that happens inside these suits. On the gloves, they're dual layer glove that we've actually added a small drop of adhesive to the inside glove so that no longer will you get glove reversal, which can be a real difficulty to deal with. If you do have to remove your hand from that glove while you're in a hot zone, you're going to, the inner glove is going to remain intact and fully functional. We've redesigned the zipper. We've put a new zipper on there that is got a large rubber T-handle on it that's much easier to close. We've changed the angle on it a little bit, so it makes it a little easier to zip in and out of. All these things are really making it easier to don and doff and easier to use. We've also redesigned, it's a simple thing, but we've redesigned the tote bag. So it's a clamshell style now where it zips on 3 sides and completely opens up so that you can put that suit back and store it a lot easier than our old design was. Next slide, please. So again, this is some of the information that you're going to find as far as permeation goes. Same type of thing. This is just a snippet of some of the chemicals that we've tested Tychem 10,000 to. There are a much wider range of test data out there. But again, to reinforce what Matt was saying, this chart has got not only the chemical name, but the CAS number. If you're not familiar with that is, that's the chemical abstract system, and every chemical has a unique number. And you can search on SafeSpec either by chemical name or CAS number. Then it's going to give you the phase. In this case, these are all vapors. And then it'll give you the breakthrough time in minutes. So again, we're very data driven. We look at permeation as the gold standard as far as evaluating chemical fabrics. And this information is all readily available on our website. And I think we talk a little bit about SafeSpec a little further on. Just note that we also offer Tychem 10,000 in a hooded coverall. It's not just a level A. Next slide, please. So one of the other things that you need to know about a level A is they need to be tested. And there's several times you want to test them. One is upon receipt from the supplier. So we test all of our level A's, give them a pressure test and a full visual inspection. Every one that leaves the factory tests out and is vapor tight or airtight. And it's important that you test them upon receiving them because we don't know what happens between when it leaves our factory and when it shows up on your door. So to have that confidence of putting one of your workers into an IDLH situation, you need to test it when it first comes in, and then you need to do a yearly test. So the test is a pressure test, and we sell a kit that you can see there that allows you to do the pressure test, and you need to do a visual inspection on it as well. And if the garment is ever worn before the garment is put back into service again, it needs to be tested. Note that if it's contaminated, damaged, or altered, it should not be reused. And there is an ASTM standard F1052 that is the standard for inflation testing. And our kit has a very good descriptive pamphlet that walks you through it. Hands-on training is also critical. So reach out to your DuPont rep. I just did one the other day where I went out to a site and trained the hazmat team on site, and we all should have our own pressure test kits that we can come out and help the end user with. So another thing that comes up frequently with all chemical garments is what is the shelf life? And it's particularly important for level A's to talk about the shelf life because there are different manufacturers out there that say that they don't have a shelf life or they have a shelf life for 10 years. And for our encapsulated level A's and our garments, we recommend that it's a 5-year shelf life from the date of manufacture. And as long as all the following conditions are met, that the suit has been properly stored, the suit has not been damaged, altered, or contaminated, it passes a full visual inspection and pressure test. And uncontaminated suits that don't pass a visual or inflation inspection those can be made for training use. It's always nice to have level A suits to train in rather than your live fire suits. You don't want to train in those for obvious reasons. You can damage them, and you don't want to have to rely on a suit that's been worn if you're going into a hot zone. So we really recommend that after 5 years, and one of the reasons is we don't manufacture the tape, we don't manufacture the gloves, and so a lot of those components have shelf lives on them. And so we kind of default to that. Next slide, please.
I will take it from here, Dan.
Okay.
So just a quick summary. We've talked about the different problems or pain points of each of these different states of matter, and what suits that we have to help against those. The other thing that we wanted to summarize too is that we have a breadth of different products. So these aren't all the ones we have. These are just examples of how we have different options out there for different situations and different scenarios within, working with those within the industrial manufacturing segment. Looking at all the suits we offer, so this is just a quick guideline chart that we have within our catalogs that shows the different options that we have, down to your non-hazardous particles, up to what Dan was just talking about, which is our level A, our Tychem 10,000, and we've got everything in between. So just a quick guideline here: the higher the number that's on our suit, the more protection against chemical challenges or hazardous particles, what have you, that it offers. So it's a very easy guideline to go against. So the higher the number, the more challenges we have. The one thing I will say is that doesn't mean that Tychem 6,000 has better protection against a chemical than 5,000. So there are certain situations where just because it's a higher number doesn't mean that it offers the same or better level of protection in terms of breakthrough time than another garment. So again, that's where it comes into utilizing our resources that we have, and I'll talk on that here in just a second. So Dan brought it up a second ago when he mentioned safe spec, and I was talking about our levels of protection, against certain chemical challenges. So what I was referring to is this. So it's our DuPont safe spec database. This is available on desktop. It's also available on mobile app as well. But what this is a full database of all of the thousands of chemicals that we've tested against our products. Everyone has access to this right now. You don't need to sign up. You don't need to order a subscription or anything like that. It's free. It's readily available. We want to make sure that everyone has access to it so they can see how our products perform, and make sure that they have that information at their fingertips. You can take this a step further on this database, and you can actually go into the environment itself. So you can look at, how is the chemical, hitting me? Is it a liquid, a jet, a splash? Where is it hitting me on my body? Am I doing a lot of nailing? How long am I going to be in the garment, right? So you can filter it down to the minute details of what you would be experiencing while dealing with these chemical challenges, and it'll essentially spit out a more filtered look in terms of what kind of suits to consider, seams, things of that nature. And then the other thing too that's just as important, myself and Dan, we're regional sales managers, and we're just a few. We're just a small snippet of our whole team. So we have coverage in every state. We are out in the field. We're ready to help. We're ready to assist on these hazard assessments, making sure that everyone is being protected the best way possible, and that the best solution is being offered up for your consideration. So with that said, that is the end of our presentation. I know I speak on behalf of Dan, but I appreciate the time, and look forward to working with everybody out in the field.
Fantastic, Matt, Dan. That was a ton of really good information in such a short period of time. I love that you put all of the challenges into matter. I think it's a really good perspective. So thank you so much for that. Before we wrap it up for today, is there anything you want our audience to take away from today to keep top of mind so that they can be successful in their PPE journey?
One thing that I would add is I highly encourage you to go to safespec.com. Not only is all our permeation data there and the guides that Matt went through, but we have PDFs and descriptions of all the garments. I would say that probably 80 to 90% of the questions I get asked, I immediately go to SafeSpec and can come up with the right answer, and then email that link or email the PDF off to the end user to give them the documentation that they need. It's really a great tool. I use it all the time, and I highly encourage you to go and play on it. It's very intuitive, and if you have any questions, reach out to your regional sales manager, and we'd love to be able to walk you through it.
Perfect. Well, gentlemen, thank you so much for your time today. We really appreciate your knowledge If you have anywhere we can reach out to you, we'd love to get that up on the screen. But make sure that you head on over to DuPont, get in touch with your reps over there. And if you have any questions, make sure you're reaching out to them. I want to thank DuPont for being here today, as well as AD Safety Network for allowing us to put this on. And of course, I want to thank all of the dedicated safety professionals for all the hard work they do on a daily basis in keeping our workplaces safe, because without them, none of this would be possible. So thanks again. Take care. Stay safe. Bye, everyone.